Okay, so we're looking for derivatives, setting it equal to 0. What I was saying is it's great to graph these things so you can look at and just see the answer. And now, you know, some people just look at the graph and then write the answer down. And I can't stop you from doing that, but that's not going to get you points on a test. And so, you know, using a picture is a nice way to lead you towards the answer, but don't use it as a crutch, is what I'm going to say. So the way we figure out whether this is a max or a min is by classifying it. And you can either use the first or the second derivative test. It's not, you're not being told which one to use in this particular problem, so you could do either one. And let me just do them both. So if you do the first derivative test, that's where you make a table and you pick some points on either side of your critical point. So if our critical point is 2, we would want to pick a point to the left of it, like 0, and a point to the right of it, like 3. And so I'm going to pick those 3 points, and we just plug them into the derivative. All right, so when I plug it into g prime, right, I'm taking this function, and using it right here, right? You get 4 minus 0, so that's increasing. You get 0 when you plug a 2 in, and you plug a 3 in, you get 4 minus 6, which is a negative number. And so this means, I'm going to zoom in right here, this means increasing, flat, decreasing. Increasing, flat, decreasing looks like this. Right? X equals 2 is a max. So that's the first derivative test, right? We use the first derivative to do that. That's not clear. I'm going to label it. I know I just drew over top of it with this, so maybe I'll just delete that. I will just write all this stuff is the first derivative test. Is that okay? Thoughts about that? We'll do the second derivative test right here. And we'll find the same answer, just a different way. Right, so the first derivative test uses the first derivative. The first derivative tells us increasing, decreasing. And so we find the flat point, analyze on either side of it to figure out increase, decrease, and that led us to seeing it's a max. The second derivative test has to do with concavity. That's what we learned about last time. Right, and so if we did the second derivative test, we just take a second derivative, which is another easy power rule. G double prime is just -2, which is always negative. And so that means we're concave down. And so that's a second way to see that x equals 2 is a max. So this is, you really need to understand this answer right now. I can't stress that enough. All the other problems are harder than this. And this is as basic as it gets, right? It's a power rule. It uses both the tests. There's only one critical point. I will not feel good about asking you to do a bunch of problems if this one doesn't make sense. So if there's a question, excuse me, let's hear it. What is it?
So the first thing that you did on the table, that's the first derivative test?
Yes, this thing on the left is the first derivative test.
Okay.
Right, I'm making a table of points around the critical point, and I'm plugging them into the derivative, the first derivative. So that's why it's the first derivative test, because you're using the first derivative. The second derivative test uses the second derivative. But each of those things tells you something different, right? The first derivative tells you increasing, decreasing, which is why we need to test on either side. And the second derivative tells us concavity. So we only need to plug the one point in. In this case, you don't need to plug anything in because it's just a constant. But you just plug the one point in, and it just tells you concave up or down. Other thoughts? Other clarificational things? Really important you ask that right now. All right, so the next one on this sheet is a similar example. I probably won't do all these out. I'll probably just set them up and maybe ask you to think about them. Someone's put something in the chat here. Sorry. Oh, you were talking about that document. Okay, I'm gonna go on to the next one. Is everyone okay with this one?
I just ask something real quick.
Yep.
So if it's a max or a min when it's flat, right? Like that point that is flat, and by the one that you have on the right and on the left, that's how you know if it's a min or a max, if that makes sense.
So this is how we know it's a flat point.
Yeah, but it's like x equals 2. It's the max because it's increasing at 0 and it's decreasing at 3, right?
Yeah, that's exactly right. Right. So this piece right here means it's going up before 2. This piece right here means it's going down after 2. Being 0 at 2 means it's flat. And so yeah, we put those 3 things together to indicate that it's a max. Yep, other things like that. It's a good one. Okay, so I was just gonna sort of mention this one. I'm not gonna do the whole thing, but it's a very similar problem, and I wanted to mention this one because it's a nice application. This is the kind of thing we really want to be able to do with this. Like this last one is a completely meaningless function, right? This g of x doesn't mean anything. Ultimately, we want to be able to say something like this. Like we've got a raccoon population, and the population is given by this function. Now we have meaning on this, and it even shows the picture, right? So there's some max somewhere right there. And so we're trying to figure out where that is, right? That's what's going on in this problem. And it's the same process. The thing I want to point out though, if we want to obtain, there's 3 questions, right? The maximum of population is obtained at some t value. The maximum population is some p value. And then there's a third question about when the population disappears, and it's also a t value. So the thing I'm trying to point out is, notice these 2 things are t's, and this one's asking for a p, right? So that's one thing. If we want to find the max population, that's the same thing we just did in the last problem. You 1, find the derivative, 2, set the derivative equal to 0. There's only one critical point because it's a squared. It's a, well, actually there'll be 2. So I'll clarify it again. Step 3 then, classify the points. So doing the exact same thing we just did, it's just a more complicated function. And since it's a t to the 4th problem, you might want to use a calculator. I wouldn't put one like this on a test because maybe it's a little bit tricky, but when you do, let me just start it here. When you do p prime, you're going to get 120. Oh, this one isn't actually that bad. I thought it was. You get 4 times 0.4, so that's 1.6. And you want that to be 0. That's not actually that bad because then you'll do a cube root and you only get one answer. That's okay then. Okay, so that's all I'm going to say about that. Is that okay? You need a calculator, maybe maybe use a website or something to take a cube root. It's going to be a decimal, so maybe you want to do that, but you can do that. The thing I wanted to point out though, the second question, where does that happen, right? The max population is what? So you find where the max happens in part 1, and then you plug that number into the formula to find the max. So you want to plug the critical point from part A into the function. What's the third question asking? The third says, when does the population disappear from the island? How do we answer that question? Nothing to do with calculus. John?
Set the
Go ahead.
Go ahead, Diana.
You set the original equation equal to 0.
Yeah, so if this thing's showing us the population, right? The population goes up and then it starts to go down, and this is where it would be 0 right there. And so we want to see where it crosses the x-axis, which means you just want to solve the population equal to 0. Right, so just set it equal to 0. That might be a situation where you might want to use a calculator or something like Wolfram Alpha, because it's not going to be an easy thing to do. Just kind of looking at that. I would maybe suggest, maybe I'll write that down. I would just use wolframalpha.com. You know, this is a home, I would not put something like that in the test where I would expect you to solve it using some computational tool or anything. But in the homework, it's certainly fair to do, especially when you've got Wolfram Alpha. You can literally just type that expression into Wolfram Alpha and it'll just show the answers. Does that seem okay? Okay, so then let's keep going and let me show you these problems. See, there's the same kind of thing. You're doing the same thing on these problems. It's just now we have more complicated functions. So let me help you set this one up. So we're looking for critical numbers, right? Critical numbers, we take the derivative. It's going to be a product rule. This is the kind of thing I'm going to ask you to do on the quiz today, or I don't know, maybe we'll do it on Monday. I'll be flexible on that. If we're having a good time doing homework, then maybe we won't do the quiz. Anyway, let's see how it goes. It's going to be the product rule. The next quiz, whenever that happens, is going to be on these kind of functions. And we want to be able to do that pretty well, right? So we've got our f and our g. And so the product rule is going to be f prime g plus f g prime. I'm not doing the details here. Let me know if you want to see it, but this is the homework that was due last week. We need to kind of be able to, you know, this is the first step in this problem, so we can't be spending like 10 minutes just working on the derivative. And not that I won't go over details, but we need to start being able to do this stuff kind of quickly. And I know a lot of people's questions were, how do you solve that equal to 0? And so that's what I'd like to talk about. But are there questions about the derivative? So when you set it equal to 0, notice how there's 2 e to the x's. And so we can factor the e to the x out. And then it becomes something that's easy to work with. Right? That's the factored form. How do you solve factored things? You set them equal to 0 separately. And so you set this equal to 0, and you set this equal to 0. And that's how we get our critical points. Right? We can factor the right side. What about the left side? People seem to be confused about that in my email. Does e to the x ever equal 0? That's e to the x, and it's got the horizontal asymptote down there at 0. So e to the x never gets to 0, right? And if you remember from solving these equations, some of you guys last semester with me, e to the x is never 0. And so we get no solution from this one. So this just nothing comes out of that one, but we'll get 2 answers out of this one. And that's how we move forward there. And just to clarify further, so that's how you get the first part, A and B. The second part in here where it talks about typing positive infinity, this is the first derivative test. Right? You plug things into the first derivative around your critical points. That tells you increasing, decreasing. That's how you answer that question. Thoughts about that one?
So for the second part, you would just make a table for each of them?
So you'll have, for the second part, you'll have a table that looks like this. Or maybe I'll do it like this. Okay, you'll have your 2 critical points, and then you just want to test something here, here, and here. Other thoughts about that one? You could make 2 separate tables, but my point is this middle one applies to both, right? It'll tell you the right side of A and the left side of B. And so you really just need to make like one table. That seems okay. Let's talk about trig. Don't get scared. Same exact problem, right? What are the critical points? Critical numbers. Take the derivative and set it equal to 0. F prime is going to be, sine turns into, I always mess this up. Sine turns into cosine, cosine negative sine. So this is going to be negative 20 sine theta. And then this is a chain rule. And we've seen that one, I think. So that's going to be plus, I'll do it like this, 10 times 2 times sine times cosine. So let me simplify that. And just in case people are curious, right, sine squared is what we just differentiated. And so you bring down the power, subtract 1 off the power, and then multiply by the derivative of the inside. That's what happened here. Except the 2 part. I didn't include the 10. Is that all right? I don't know if the derivatives are tripping people up. So we want that to be 0. And I'm noticing that we can factor a sign out, right? There's a sign in both those terms. And so we can factor a sign out and do, we can factor 20 sign out actually, and do minus 1 plus cosine. And we just do the same thing, right? We now have it factored. You set each factor equal to 0 separately. So this one gets set equal to 0. This one gets set equal to 0, and it's going to turn into cosine equals 1, right? How do we feel about trig? I know the guys who took with me last semester, man, you guys are going to love this. You're just on top of this one, but, and I'm just being sarcastic. Do people want a little bit of review how to do those things? I don't know how much I can do here, but I'll say something about them. Questions on up to this point first?
The only part about this problem that tripped me up was sine to the power of 2. So you just bring down the 2, put it in front and multiply it by the, looks like on yours it's 10.
Yeah, that's right. So if we had the sine, well, it's really a 20 sine squared or 10 sine squared, I guess, right? So we're thinking about that as being the outside functions like 10x squared, and the inside function is sine in terms of the chain rule.
Okay, that makes sense. Thanks.
Yeah, anytime you have a trig function squared, it's something inside an x squared. It's a chain rule. Other thoughts about that one? Okay, I'm not going to maybe go into details about solving sine and cosine. I can send around, I know I've said that, no one's asked me for any information about it, but you can also use a calculator to solve those. I'd like to let you start working on these in a second. So those are my max min answers. I also have some ones, these next 4 are from Concavity.
This problem gave me trouble.
Okay, I was actually just about to skip this one, so maybe I won't. So the questions are about being concave up and down, right? And inflection points. So let me actually color code this. Let's do concave up in red. We'll do concave down in purple. And I will dot the inflection points with not blue because the graph is blue. How about black? So concave up looks to me to be this part. And this appears to be concave up as well. Agree with that? And I think that's it. Yeah, go ahead.
I'd agree, but I've typed it in multiple times in WebWorks and put the interval notation and it just hasn't worked.
Okay, and I would think that this part is the down part. And so with that in mind, the inflection points are where it changes, right? So one of them is going to be right here. And one of them's right here. The picture look okay?
Yep.
So interval notation on this. Interval notation for the first one. And notice how it's saying open intervals. That means we want to use parentheses. I don't know if that was your issue, John, but maybe that was it. So to me, this one looks like it starts at 0 and goes to 2.
Yep.
And then union that with, what is that? 1, 2, 1, 2, 3, 4, 5, 5?
5 to 8. Yeah, I have
5 to 8.
I have that. It doesn't work.
Let me make sure I've got the right answer. Oh shoot, what number is this one?
It's 3.
3.
Maybe for the union, sometimes you just gotta put what's it called?
The capital U. So that's right. That's right. And based on this answer, maybe you need to get them all right and you're messing one up. Let's finish it and see if that's okay.
Okay.
The middle part then is the ones between 2 and 5, right? So it would be
So just 2, 5.
2 to 5. And then it wants the points listed like this, A comma B. So the 2 inflection points then are 2 comma 1, 2, 3, 4, 5. And what does it want? Separated by commas. So comma 1, 2, 3, 4, 5, comma 1, 2, 3, 4, 5, 5, 5. I think that's right. Oh, okay. I'm looking at the answer now. It's it's trying to get us to think about, and I totally missed this too, so I'm glad we're talking about this. This point right here, is that an inflection point? That's a corner that's screwing us up. And so it's not concave up or down there. And so we need to break this middle interval up.
Oh, so 2, 4, 4, 5.
Yeah. Yeah, I'm sorry that one was so annoying. I would recommend everyone kind of doing this one now, just so they have that. Yeah, so that's a corner down at the bottom there, which is not concave up or down. It's one of those special cases. I think everyone's is the same picture on this one too, if I'm not mistaken. Does that one seem okay?
It's still wrong.
Yeah, I put it into WebWorks too, and it still says it's wrong.
Like conceptually, I understand the problem, but like I just typed it in so many times, it just hasn't worked.
It's working for me. Let's see.
It's one of the ones that says like like all of them have to be correct, and it says that at the bottom you have received a score of 0% for this attempt.
Yeah.
Let me just see if it will take mine. This is definitely correct. Yeah, that worked for me. Are you using a capital U? Let me see if it doesn't like that. It's not like that. Does it say U is not defined? So it's got to be a capital U. And otherwise, I entered those exact things in there.
Maybe because it's not a continuous graph.
Let me just look at John's answer real quick and I'll just get to the bottom of this. Okay, so the graphs are slightly different. So John, your corner is at 5, 1.
I just got it.
So the graphs are slightly different. It's the same shape, but it's moved up or down. So you might have to adjust some of your answers a little bit.
Yeah.
Anyone else still having issues? Okay, then this is important. I'm trying to make this sure this is important because the whole set's about concavity. So we should, this graph should make sense. If we want to find inflection points, so this one's about finding the inflection point, right? Where is the inflection point? This one's also about where is the inflection point? That's where we want, is this one too? Yeah, where is the inflection point? That's where we want to solve the second derivative equal to 0. That's what we're trying to do here. And it's ugly because it's a product rule and it's going to be a double product rule. But this is the kind of thing we need to be able to do. So f prime is going to be a product rule, which is f prime g plus f g prime, right? Derivative of e to the x just stays the same. And the other one's a power rule. And then when we do f double prime, it's just 2 product rules. And I know like this is the kind of thing where people start rolling their eyes and being like, wow, I can't believe this is so annoying. It's really not that bad, especially if you just understand the general rules. And then once we move forward with it, it's not going to be bad either, trust me. Right, so the first product rule ends up being f prime g plus f g prime, right? E to the x is just so nice. You almost don't have to do anything with it. And same thing with the other one. F prime, and that's the same thing actually. We just did that one a second ago, so we're just copying down the same thing. It's going to be f prime g plus f g prime. And yeah, it's horrible. We want it to equal 0. It looks terrible. But when you just pull the e to the x out, right, there's an e to the x in each term. It ends up just being e to the x times a polynomial, a quadratic even, which is not bad. Thoughts about the derivative? So when you factor e to the x out, it becomes 2 plus 2x plus 2x plus x squared minus 8. In other words, x squared plus 4x minus 6. Right, not so bad. I'll let you think about this one more, but I'll just go ahead and tell you this one. This is never 0, right? E to the x is never 0. And so it's only, you're going to get 2 critical points from the middle part. 2 inflection points, excuse me. Thoughts? Got several answers or several questions about this one in particular. Or e to the x doesn't do anything when you take derivatives. So when you have that inside rules and it ends up being in every term usually, and then you just end up factoring it out, right? We've seen this twice today. I think there'll be another one we'll see it. You've got a bunch of e to the x's, you just end up factoring it out, and then it just doesn't even factor into the answer because it's never 0. Anything there? Seems okay? All right, these two are the same kind of problems. I would love for people to start working on this stuff, so maybe I'll leave this one for you. I was just going to do this one because it was a trig function. I think someone asked about it, but same kind of thing. If we want the inflection point, we want to solve the second derivative equal to 0. And that one's not actually that bad, so I'm going to, yeah, the second one is just going to end up being like sine equals something. Oops, not 0. So that one won't be terrible. Maybe I'll just start by doing the derivatives on this one. I don't know if that's tripping people up, but same thing. We're going to take 2 derivatives. So the first derivative, it's a chain rule. So it's going to be 1 over what's inside there times the derivative of what's inside there. That should be a plus, sorry. Right, which is going to be 2x over this. And so then when you do the second derivative, it's going to be a chain rule. I mean, a quotient rule. But not a bad one, because there's a bunch of polynomials that are actually not too ugly. Your second derivative is going to be a fraction, and you want that to be 0. How do you solve a fraction over 0 to equal 0? I think I mentioned this the other day, but it's good to mention again.
Set the numerator.
Yeah, you just want the numerator to be 0. So you might have some nasty denominator. All you want to do is just make the top be 0. Right, so if you had something like x squared over some horrible thing, x plus 4e to the x ln of sine of x, I don't know, some horrible thing in the bottom, and you want that to be 0, the bottom is irrelevant, right? It just becomes x squared equals 0, and you just get that from the top, just as an example. That's just an example of what might happen. All right, at this point, I think I'd like to cancel the quiz, which is hopefully a relief. I do want to look at that though, because I want, that's going to be what's on the test next Friday. So we'll do that on Monday if that's okay. We'll just do the same thing at the end of class and just let you work on that. But for the last half hour, now that we've kind of think about this, love to break people up into groups and let you work on these. Are there questions before we do that? Anything else on your mind before we do that one?
I'm still having troubles with the concavity part, problem 3.
Okay, I will maybe join up with you after I split people up and we can look at yours.
Okay.
I'm going to put John and Kyle together just because I think they have the fewest questions. Maybe they can find some common ground. They're the people who have most of the homework done. Does anyone else want to join that group who feels okay about this and doesn't necessarily want to do all the work? Okay, no problem. So I'm going to put John and Kyle together, and maybe you can find some common ground, or I'm happy to go if there's something that's you're really stuck on, I'll come over and help you. And then everyone else, myself included, maybe not everyone else, I'll split it up into two or three groups. Yeah, I'll do a couple other ones. All right, I'm gonna try to pop through these rooms, but raise your hand, or I think you could reach out to me. I would love to come, and if you don't get stuck on something for a while, actually let me help you. And share a whiteboard. I would love to come in and see you guys actually talking and working on this stuff. You got to do this stuff tonight anyway, so it'd be nice if you could help each other. All right, let's do it. Let's do it. All right, everyone's back. Great. So thank you for your work in there. Someone else is still joining. Let me wait 1 second. Okay. Thank you for working in groups and talking about that stuff. These are involved problems, and I hope people that didn't start the homework are realizing that was a mistake. This is a long homework set that's going to take some time. Having said that, I don't really intend on extending homework for anyone who isn't going to give a good effort tonight. So the flip side of it is, what I'm trying to say is, I'm willing to extend this homework, provided everyone gives it their best tonight. If I go in tomorrow and half the class still hasn't started it or hasn't done more like half of it or whatever, then I'm only going to extend it to people who are trying here. That's what I'm trying to say. And if you want to meet to talk about derivatives, like the derivative part is the part that's preventing you from being successful on the max min homework, then we really, really, really need to meet as soon as humanly possible, because the test is going to be next Friday. Can I answer some last minute questions? Oh, so I mentioned there's a couple problems that deal with maxes and mins on an interval. So that's specifically question 2. I thought I saw another one somewhere. A couple of the trig functions do that, but that shouldn't be a problem. Oh, 2 and 11. Let me put that in the chat. Problem 2 and 11 in the max min homework are on an interval, and I'm happy to look at that one a little more carefully together. We have the techniques to do that, but I know we didn't specifically talk about finding a max and a min on an interval yet, so don't fret over those. We can do those together on Monday as well. So that's all I've got today. I know the class is over. I'm happy to stick around if people have other questions. I've got my other class at 12:30, so if people wanted to keep working on homework and join another group and keep going with this, you're welcome to do that starting at 12:30. But that's all I've got. Thank you very much. I'll post this video. I don't know if it's going to be very helpful or not, but it'll at least have the stuff from the start of class where I worked on some of those problems. Questions or anything? If not, thank you.
Thank you.
Thank you.
I'd actually like to stay with the other class.
Yeah, same here.
Cool. That sounds good. I'm going to get a few things ready for that, but let me know if you keep working on it now. If you've got some questions, you're welcome to do that. Hey everyone, let's go ahead and get started here. Okay. All right, so if you look at the schedule for the whole semester, we're a tiny bit ahead here. We're like a day ahead, which is good because I'd like to dedicate this day just to looking at homework, the homework that's due tonight. And I even went ahead and just pushed one of the smaller assignment, the last smaller assignment, back to next week. There's 2 assignments due tonight. I think it's about 23 problems or so, but they're involved problems and people are having a lot of trouble with them. And I've been getting some, well, people who are working on them are having trouble with them, which is making me concerned about how many people haven't been working on them. Those people are probably also gonna have problems. So anyway, my goal here is to summarize some of those issues and let you guys work on these in groups a little bit today. Yeah, and what ended up happening in my last class, which just ended a minute ago, was we just used the whole period. We didn't even have a quiz, so we're not gonna do the quiz today. We're just gonna use the whole period on these homework problems. What I'd like to do is make the quiz on Monday. Do that on Monday instead, just remotely as well. And just fully focus on maxes and mins and concavity during class today. And so let me go ahead and share my computer screen. So let me stop sharing this one. What was I going to say? I was going to say, if you look at the homework sets, these are the 2 homeworks that we're going to focus on today, max, mins, and concavity. And I posted this document to Blackboard that you should open up. So I picked out some specific problems from each one of those homework sets and just put them into this document. And so what I'd like to start by doing is just summarizing some of the details related to each one of these things, each one of these problems, maybe not doing all the problems, but maybe setting them up and then asking you or letting you just using the rest of the class in small groups and see how many you can work through. And that gives me a chance to sort of pop through in small groups and see how things are going and give you some sort of personalized help. So that's the plan here. You should open this document up if you haven't opened it up yet. Again, it's right at the top of course documents. If you go to course documents in Blackboard, it's right at the top. And again, what I'm going to start doing is going through that document before we go into groups. Can I answer some questions though? Is there anything on your mind before we start with that? Is there anything else you're interested in hearing about or talking about before we do that? Okay, so I'm going to start with those problems. Again, you should open that up. As I'm preparing that, I'm just going to sort of mention that it'd be great if you turned your camera on. I didn't make this a remote class so you could like sleep. And ultimately what I'd like you to do is work in groups, and that's going to involve you interacting with people. And so it'd be good if you started just getting with the program here and participating and all that stuff. I'm sympathetic to student needs. I just want to be clear about that, but I'm not sympathetic when people aren't like put forth 0 effort. Not that anyone's doing that, but the number of people who have not started the homework tonight is concerning, to say the least, considering how challenging this is. So let's go. Let's get it into gear. That's what I'm trying to say. Get it together. Okay, so the first, I picked out 4 problems from each homework set. Is everyone able to find this document okay? It's right on Blackboard. I'm going to do the first problem and then just set the other ones up, maybe do part of them and just give you some things to think about, let you ask some questions and see if this makes sense. So maybe I'll just quickly start by summarizing 2 things. The first derivative tells us increasing or decreasing, right? And the second derivative tells us concavity. And so we're using both those concepts here. And anytime we're being asked for a critical point, like in this one, we're asked for the max and min, right? And this one, we're looking for the maximum. On this one, we're looking for critical numbers. All these things are sort of saying the same thing. Critical numbers, all the critical numbers, max, mins, we find those by setting the derivative equal to 0. And so you take the derivative and you solve f prime equal to 0 to find max and mins. And inflection points sometimes. So maybe let me just rephrase that. To find critical points is what we should say. And so that's what we should do in this problem. If we want to find the max and min, we should take the derivative and set it equal to 0. This is a nice power rule, not too bad, right? So the power rule just becomes 4 minus 2x. We want that to be 0. So it gives us a nice, not too bad equation to solve. Is that okay? Just trying to get my notes out here. Okay. And so that, when we set that equal to 0 and we solve it, let me actually double check the chat. Okay, I got the chat open too. I'm ready. So when we set that equal to 0 and solve, it's easy, right? Just we get x equals 2. And so it's an x squared kind of thing. And so there's only going to be one critical point. And then we just want to classify that critical point. So let me move that out of the way a little bit. Is that okay? So to classify, this is the thing we've been working on the last week plus. You can either use the first derivative test, or in another color maybe, we can do the second derivative test. And this problem doesn't specify which one to use, and so you can use either one, but I'm just going to do both of them just because if we have one written down with all the details, hopefully that'll help us think about this. Right, the first derivative tells us increasing, decreasing, like it says right at the top of the page. So if that tells us increasing, decreasing, the way we do the first derivative test is we create a table and we plug in points on either side of our critical point, right? That's the critical point. And so we pick a point to the left and to the right. So to the left could be 0, to the right could be 3. And we just plug them into, so these are our x values, we plug them into the derivative, right? It's the first derivative test. So we're plugging them into the first derivative. When you plug in 0, you would get 4 minus 0, which is a positive number. When you plug in 2, you get 0. And when you plug in 3, you'd get 4 minus 6, which is negative 2. And so this tells us increasing, flat, decreasing. What does increasing, flat, decreasing look like? Increasing, flat, decreasing. It looks like this. And so that's how we can figure out x equals 2 is a max. That's the first derivative test, right? First derivative tells us increase, decrease. That's like, before I just did this in my last class, I was popping around the rooms and lots of people were trying to do this stuff without really even remembering what the first and second derivative tell us. Like before you do anything on this homework set, what I'm boxing in red right now needs to be critically clear in your mind. I'll do it in thicker red. Right? First derivative tells us increasing, decreasing. Second derivative tells us concavity. We don't understand that, then we can't do these problems. First derivative test seem okay? Any thoughts so far?
I have a quick question for you, Professor.
Yep, yeah.
Did you pick the x values 0, 2, and 3 because after plugging in the formula to equal out 0, you got 2, so you picked a number above and below it?
That's right, yeah. So we know that 2 is the critical point. And so I just want it to be somewhere on the left and somewhere on the right. And so 3 is 1 more than 2, so I picked 3 over here. And then 0 is a little bit further, but it's just an easy number to pick, or to plug in, which is why I picked 0. Yeah.
All right, thank you.
Other thoughts? Okay, so that's the first derivative test. The second derivative tells us concavity, right? So it tells us, is it bowl-shaped upwards or bowl-shaped downwards? And so if we want to do the second derivative test, we just take the second derivative, which in this case is also an easy power rule, just becomes -2. Right, does everyone see that? If you just take this derivative, it becomes -2. So there's no x in there, in other words. And so g double prime of our critical point is always negative, i.e. it's concave down. So it's a flat point from the first derivative being 0, and it's concave down from the second derivative being negative. That also tells us we have a max. So the two different ways to tell us that we have a max at x equals 2. What can I clarify about this? It is unbelievably critically important that this one makes sense, right? Because this is it's a polynomial, it doesn't get any easier than that, and all we're doing is just finding a max or a min. If you look at the future problems, they're a lot harder than that one. And you know, they're more involved is what I'm trying to say. They're not necessarily harder, there's just more stuff to do. So like this one needs to make very clear sense to us, have a chance at getting the next ones. Can I clarify something about that? Okay, this document's in the Dropbox, by the way, if you wanted to open that up. The document with my writing on it, that is. So I'm just going to set this one up. So this is the same kind of population, same kind of problem, but now it has meaning, right? So now we have a raccoon population. The raccoon population has this formula, and then it has this graph, right? And so we're asked some questions about it. There's obviously a max right there. We're trying to figure out where that is. And that's what this problem's about, right? So now we're applying what we know to a problem that has meaning. And so there's three questions. There's finding the max at where's the t value. There's finding what the max actually is. And then where does the max go away, right? So two of those things are t values and one of them is a p value. If we want to find the max, this is the same question we just worked on. You, 1, solve p prime equal to 0. 2, classify the critical points. Right, just like from the last problem. And then, so that'll tell you where the max is, right? Once you find the max, the second part is saying, what is the maximum population? So you find where it happens, and then you plug that number into the function, right? So the second part here would be plug in the max from the first part into the function p. And then the third question saying, or asking, when does the population go away? When does that happen in this graph? If this is the population on the y-axis, when is it 0?
When y equals 0?
Yeah, down here, right? So the population equals 0, where the y value equals 0, exactly. And so if we want to know where the population disappears, we just want to solve p equal to 0. And in this particular problem, it would be this. Which is actually a pretty tricky thing to do by hand because it's got a fourth power in there. It has a t and a fourth power. So this is actually kind of hard to do. So I would suggest using a calculator or something like Wolfram Alpha or something like that. So I wouldn't put one like this on a test where you need a calculator, but I like this problem because it's a real world application, right? It's something that you actually, it's the kind of thing we're trying to build towards, right? Thoughts about, you know, these are the two basic questions. We want to understand these two before we get into the harder ones. Okay. All right, I'm gonna slide down to this one then. So, you know, obviously we're just making the functions more complicated. So if I can erase this, this is a more complicated function because when we want to do the critical points, we want to set the derivative equal to 0. And when we do the derivative, it's a product rule. And this is the kind of thing that's on the quiz that was going to be today that will now be on Monday. I'm just going to ask you just to do problems like this, like what's the product rule? And so the product rule on this one looks like this: f prime g plus f g prime. Right, hopefully that makes some sense. You can think about that a little bit, but that's where we want to basically go with this one, right? F prime g plus f g prime for f and g. And the emails I've been getting have been a lot to do with how do you solve this equal to 0, which I want to talk about next. But are there questions about the derivative part first? Okay, so for critical points, you want to solve that derivative equal to 0. And so how do you do that? We want this to be 0. Right, that's what we're trying to think about here. And yeah, that's really kind of crazy looking, but anytime there's an e in the problem and you take derivatives, it just stays the same, right? E to the x stays the same. And so that's nice because what it ends up being in a problem, usually you can factor it out, right? So there's an e to the x in both of those terms. And so you can factor an e to the x out and do that. And that's how we move forward in this problem, right? That's now factored. And so you can set the two factors equal to 0 separately. Is that okay? And the one on the right's nice because you can just factor that one. That's not too bad, or use the quadratic formula. What about e to the x? Is e to the x ever 0? E to the x looks like that. And we'll remember that there's an asymptote down here, right? So e to the x never touches 0. So anytime you're trying to solve an exponential equal to 0, it just, you get no solution out of this one. So you don't get anything from this piece. You're just going to get 2 critical points from the right-hand part. Thoughts about that? So notice the second part of the question. The second part of the question is, where is the interval, or on what intervals is the function increasing or decreasing? Or on what intervals is the derivative positive or negative, which is the same thing as saying increasing, decreasing. Right, so for that point, for that problem, if you want to do this one, you're going to get critical points from the first part, right? So you'll have critical point 1 and critical point 2. And then you just want to test some values in between them. That'll tell you increasing or decreasing. So you test them in the derivative, of course. And that's how you fill in that table right there. Right, the critical points is where it flattens out. And so in between the critical points, it must be either increasing or decreasing. So you find the critical points from the first part, just do the first derivative test. That's what this is doing, right? You're doing the first derivative test here. And that's how you answer the second part. And you'll be able to answer the third part too. You'll be able to get the maxes and mins out of that. So again, I'm just trying to clarify the problems a little bit and help you think about them before I let you work on them a little bit yourself. Is that okay? Okay. All right, if we're doing trig functions, I just wanted to at least talk a little bit about trig functions. So this is a trig function one where, again, we're just trying to find critical points. So we just want to differentiate this thing. We want to do f prime. But the thing that I think was tripping people up in my last class, at least, was this term, right? When you have something that says 10 sine squared, that's a chain rule. And I think people were not recognizing it as a chain rule. Right, that's a chain rule with the outside function being 10x squared and the inside function being sine. Right, so when you differentiate that, so based on that, when you differentiate 10 sine squared, you should get 10 times 2 sine. Move this over a little bit. 10 times 2 sine times the derivative of sine. Anyway, I don't know if this is what's tricking people up in this particular class, but in my last class, this was the issue. Does that one look okay? I'll write down the full derivative in just a second here, but I just wanted to focus on the sine squared for a moment. You know, I know it's hard sometimes to connect things from past classes or homeworks moving forward, but this is the kind of stuff that was in the homework last week, right? Chain rule, things inside x squareds. We now need to be able to recognize that in these problems just as the first step, right? That's the first step in these problems. We're building on this stuff kind of quickly. Everyone okay? So the first derivative then, if we wanted to do the first derivative, that's going to be part of it. With the cosine becomes minus sine, and then we have that piece. So 20 sine theta cosine theta. And we want that to be 0, right? We're trying to find the critical points. That's what we're doing right here. And again, this is a factoring problem, right? I've got a sine function and a sine function, so I can factor out the sine function. I can factor out 20 sine, actually, so you can factor out 20 sine theta and obtain -1 plus cosine. And that's nice because you just, again, you set those two separate pieces equal to 0 and you get something that you can work with. Questions about that? I don't know if you guys are scared about trig or not, but you shouldn't be too scared. I mentioned this a bunch of times and I keep offering to help people with it, send material. No one's taking me up on that, so I'll just say it again. If you're scared of trig or worried about doing that, it's really not hard, I promise you. Just need to look at something that you don't remember, which is fine. But I can't do that for you, I guess is what I'm trying to say. So let me know if I can help you. Is that okay? Feel comfortable finishing that one? Okay, so ... solve for theta. So these are all the max-min problems. I just did 4 kind of summarizing max-min homework questions. These ones are from Concavity. Seems okay? So this first problem is just asking us to look at this graph and think about where is this function concave down or up, I guess first. I'll do it in colors. Where is it concave down? And where are the points of inflection? Right, so concavity means the curvature. So if I just think about the concave up parts, concave up looks like this piece. Kind of boxing it in, right? That looks up to me. And then the end piece, this is also up. And then down is in the middle there, but there's this interesting thing that's happening right at this point right there, which is a corner. And so it doesn't have any concavity is the idea. And so the middle part's kind of confusing. So this piece is concave down. And then the other piece is also concave down, but it's two separate pieces because it's broken up by the corner. But the corner is not an inflection point, right? Inflection point is where it changes concavity. And so it does not change at the corner. It's concave down before the corner and it's concave down after the corner. So it's not changing. It only changes right here and right here when I'm drawing green dots. So there and there are the inflection points. Right, again, it changed concavity there. How do folks feel about that one? People had a hard time entering this one, and I was struggling with some folks to work on that. So I'm happy to do that with you, but just know that you're gonna have 2 intervals in the first one, 2 intervals in the second one, and 2 points in the third one. All right, what about this? So this is again about concavity. It wants to know the inflection points. Inflection points happen where the second derivative is 0. And so we want to take 2 derivatives on this one, and it's a double product rule. Right, so if we do f prime, it's going to be a product rule. And f double prime is going to be 2 product rules, basically, right? So the first product rule looks like this: f prime g plus f g prime. Right, that's the first product rule on the original function. Take a look at that and let me know how you think about that. Derivative of the first, and e to the x is nice because it doesn't change whether we take the derivative or not, right? So e to the x just stays the same in both cases. But what's annoying about this one is when we do a second derivative, we have 2 product rules. Right, they're each a product rule now, but neither of them are hard because they're power rules and e to the x just stays the same. So it's really just kind of basic applications of product rules, right? The first one would be f prime g plus f g prime. And then the second one, f prime g plus f g prime. Is it ugly? Sure, it's this big long thing and it's got a bunch of e's in there. But it's not horrible. It's really not that bad, right? But just a couple power rules. E to the x literally doesn't change. So it's not that bad. And then this, we want this to be 0, which I understand, like, wow, how are we going to set that equal to 0? If you don't think about it too hard, it looks impossible. But I'll say again, anytime you have e to the x in these problems, usually it just factors out. And this is another one of those cases, right? Each one of these terms has e to the x in it. So we can just pull e to the x out, and then we'll just have a nice, easy thing, a nice, easy quadratic to solve, right? That's not so bad. This is just e to the x times x squared plus 4x minus 6. Heck, that's not bad. So that's how we'll find our critical points on this one. Right? This one is not 0 ever. You're going to get 2 critical points from this. Sorry, 2 inflection points. Thoughts? I'm just hoping that this is, you don't have questions because it's just super clear. Again, I'm just a little bit worried that people don't have questions because they haven't started things and they're super lost. And if that's the case, like, I don't know what else to say, then you waited to the last day to start the homework. I encourage you to not do that next time. This next one, I decided not to do this one in my last class, and I probably won't again. I think when I was originally looking at this, it looked confusing. But we want to look for inflection points again. And so we're just going to solve f double prime equal to 0. But it's actually not that bad. You're going to end up with like sine of theta equals something. And so it's a trig one, but it's actually not a terrible trig one. So just in the interest of time and letting you think about that, I'm going to skip over this one. But maybe you can work on it together in groups if that's something you're interested in. I did want to look at this one briefly. Why did I want to look at this one? Oh yeah, because so again, we're looking at inflection points. Right? Where does it say that? Concave up and down. We're looking at concavity, inflection points, right? All these things imply the second derivative. And so we should take two derivatives. But the interesting thing about this one is the first derivative ends up being this. Right? It's a chain rule, right? This is a chain rule. It's a chain rule with the outside function being ln and the inside function being 4 plus x squared. And so that's how you get that answer, right? And then I just want to point out that when you do f double prime, you're going to get a quotient rule. Right? And so f double prime is going to be some fraction, and you want that to be 0. And people get super flustered sometimes when I think about fractions and trying to solve fraction equations. And so I did talk about this before, but I just want to remind you, if you want a fraction to be 0, goodness, come on. If you want a over b to be 0, you need just the top to be 0, right? So if you have some big complicated fraction with nasty stuff in the denominator is irrelevant. You just take the numerator and you make that part 0. Okay, so I think I've set up the problems. I'll just sort of let people finish writing this one down, and I would be happy to clarify some things. But the idea here is we have, 45 minutes left, 40 or so minutes, where I'd love people to work through some of these. My hope was we'd just be finishing off answers because people would have looked at this stuff ahead of time, but that didn't happen. So what we'll do is get as far as we can, and I hope this will encourage people not to wait so long.
Can I ask something?
Yeah.
So question number 1 for max mins, the one that you were doing before.
Yeah.
It's kind of stupid, but I just can't understand it. So I know how to, like, I got the max, the global max, I got it right, but how do I get to the global min?
So that boils down to just reading the question carefully, right? We only found one critical point. So there's only one of those two things. There's a max or a min. We can't have both of those things with just one critical point. So it says if there's none, you should just enter none. All right, so in the min part, you would just enter the word none.
Oh, okay. Thank you.
Some other questions, and I go back to this one in case anyone was writing it down still. Any other things that you're not sure about how to start these problems? Or anything I said that was confusing? Ideally, we could break up into groups of people who have been working on this and people who have not yet started. And I have some carryovers I know from my last class, which is great. And so maybe those folks at least want to work together because they at least have seen this stuff before from last class. Is anyone else interested in being in a group where people are working on stuff? Like, for example, Amon, I know, has worked on a lot of these problems. What else is in here? Rory has worked on a lot of these problems. Is Rory in here? I thought Rory wasn't here. Maybe not. Oh, yeah, there's Rory. Rachel's just about done, if not done. So maybe I'll put those folks together. So here's what I'm thinking, and you can correct me if I'm wrong. I'm gonna create some breakout rooms. Looks like some people already went there. I'll recreate this. I'm going to create some breakout rooms. I'm going to do them manually. And I'm going to put people who have started working on this together. And you can let me know if you don't want to do that, but that's my idea. So I'm going to put the people from my last section together. So that would be Gregor, Janetta, Jorge. Is that it? I think. I'm going to pick people who have been working on this already. So that would be, I think, Amon, Rachel, Rory. Is there anyone else who has been doing stuff that I'm missing here that would like to be in a group that is familiar with the problems and just needs a little bit of help? Okay, so those 3 folks will be there. And then that means everyone else is going to get broke up between the rest of the group. So how many people are left? 3, 6, 9. I'm going to do groups of 3 here. And so I'm going to, open these rooms up in a second. And the idea is to take what I just did, and if you lazily didn't write anything down, that's in Drop, it's in the drive if you want to open that up, and try to work through some of these. Share a whiteboard, press the share button, and actually talk to each other. I was a little disappointed, still disappointed to see so many people without their cameras on. I can't force you to do that. And I read this great thing the other day. I do Reddit a lot. I'm on Reddit a lot, and I'm on our professor, and someone was saying like, oh, the students are always like saying sorry to me when they miss things. And someone said, oh, well, never someone says sorry. I just tell them, hey, this is your education. And if you don't want to do well in it, I'm not going to be offended. And I need to start having that like viewpoint. If you don't want to take this seriously, if you don't want to participate, you want to do your own thing, you do you. But I'm not going to feel bad when you're like struggling, right? I'm trying my best. And if you don't want to try, that's fine. I'm not going to be offended. But I would really encourage you to. This is how you're going to get something out of this class, and you're here anyway. You might as well try. Anyway, that's my pep talk. I'm going to open up rooms. If you need something, call me. I don't know how you can do that, but you can call me in there, and I'm going to pop through rooms and see if how things are going. Are there questions about anything before I split up? I'll get us back together right at the end. Are there questions up?
I have a dumb question.
Oh, I opened them up. Yeah, go ahead.
Never
go ahead.
mind.
You can ask
I was about to ask how to join the breakout room because usually I would just watch the lectures on YouTube, but I just got a window.
Yeah, I just opened them up. So there should be something that popped up that let you join them now.
Yeah, no, thank you.
Sure. All right, welcome back, folks. Thank you for your efforts. And this is tricky stuff, you know, especially when you start digging into some of the harder problems. And I hope this is a little bit of a wake-up call to sort of, I try so hard to like work on homework problems in class and stuff, but if we leave hard homework to the last day, it doesn't give us much of an option. So having said that, we still are in a good shape in terms of our class schedule. And so what I had told the last class was I'm willing to extend this one, maybe to like Monday night, but it's going to require people to put in a significant effort tonight. And it looks like, where did these people go? It's like lost half the people. Anyway, I'm gonna, I'll extend this homework tomorrow for people who have tried. And so, and I just say that because I feel like if I say I'll extend it, no one will work on it, and about half the class hasn't even started it. So I really need to see effort. I can't stress that enough, and I'll extend it, and we can look at some more on Monday. Questions before we break up here? It's like about 6 people already left, but that's okay. Can I clarify anything else? I've got another class I've got to get to, but anything?
Will this lecture be put on YouTube by tonight, or?
So it's been recording since 11. I don't know what it records when we do breakout rooms. I think it just sticks with me probably. So yes, I'm going to post whatever was recorded. It'll at least be like the first part where I went over some problems. I don't know exactly what happens in the intermediate part, but it'll be up on YouTube.
All right, thank you.
Having said that, I've got another class right now. It takes some time to process, so it won't be up till a little bit later. Anything else? All right. Thanks, guys. Have a good weekend.
Have a good weekend, Professor.
Thank you.
Yeah.
You too, Professor.
Thank you.
Bye.